For the last few years, artificial intelligence has acquired massive processing power. We've built digital engines capable of absorbing the entire internet. Yet, despite this raw capability, the technology lacks discernment. This graph maps prompt complexity against computational effort. In computer science, a system is inefficient, or plainly spoken, dumb, when it lacks flexibility. Legacy AI systems draw a perfectly flat horizontal line across the board. They apply the exact same processing intensity to every single prompt, regardless of what you actually ask. Imagine a math student sitting down for an exam. They spend exactly 20 minutes of intense, agonizing calculation to solve 1 plus 1. Then they flip the page and spend that same exact 20 minutes trying to prove Fermat's last theorem. Applying maximum effort everywhere is simply exhausting, inefficient hardware operation disguised as deep thought. Because of this flatline approach, daily usage becomes highly abrasive. When you ask a legacy model to check a date or format a quick grocery list, you sit there waiting. The system insists on running through deep, unnecessary processing layers for a question that requires a split-second factual retrieval. The exact opposite problem occurs when you hand the AI a massive legal contract or a multi-step logic problem. Because its effort allocation is fixed, it runs out of computational runway. It delivers a shallow, undercooked analysis precisely when you need it to think the hardest. To bypass these limitations, developers force the user to step in. We manually toggle deep think modes, adjust system parameters, and actively babysit the software to get a usable output. The human operator ended up providing the cognitive discernment that the machine itself lacked. In April 2026, Anthropic released Claude Opus 4.7, introducing a new mechanism called adaptive thinking. Adaptive thinking allows the AI to act like a highly perceptive executive assistant. Before it processes a single word of its response, it instantly judges the cognitive weight and complexity of your prompt. This animated flowchart shows how Opus 4.7 integrates the Pareto principle, the 80-20 rule, into its core architecture. As incoming tasks hit a central sorting node, the system automatically routes them. 80% are diverted into a thin, high-speed green lane for simple queries, while the remaining 20% are sent down a wide, heavily reinforced blue lane for complex logic. Look at the high-speed green lane. For everyday tasks like drafting a quick email or checking a time zone, Opus 4.7 deliberately bypasses its own deep reasoning centers. The result is blistering speed, frictionless, instant answers without the lag. Over in the complex blue lane, the strategy flips. When handed a coding challenge or a deep analytical task, Opus 4.7 takes all the compute power it saved from the simple queries and reroutes it here. It processes methodically, slowing down to think deeply before outputting a single character. This automated capability achieves a crucial balance, judging when speed is appropriate and when deep, sustained thought is required. Think of a legacy model like the chef on screen here. No matter what you order, he spends exactly 2 hours cooking it. You endure an infuriating wait for a simple bowl of plain noodles, and later receive a disastrously rushed, half-finished banquet. Opus 4.7 operates exactly like a master chef who perfectly matches their prep time to the specific dish requested. That bowl of noodles is out of the kitchen in 5 minutes flat, while the multi-course feast receives 24 hours of careful, dedicated preparation. This variable approach to effort separates a rigid machine from a truly intelligent digital partner. For the daily user, adaptive thinking entirely removes the burden of predicting how hard the software needs to work. We are moving past the strict technical requirements of prompt engineering. You simply state what you need in natural conversation, and the AI intuitively sets the correct processing rhythm on its own. Until recently, getting a decent result meant endlessly tweaking system parameters, adding specific trigger words, and micromanaging system settings to force the software to pay attention. True technological ease happens when the software fully absorbs the cognitive load of decision-making from the user. There is a secondary, highly practical impact to adaptive thinking. It drastically reduces the overall cost, time, and server drain of daily AI usage. This diagram tracks the do-over drain of legacy systems. When an AI fails at a complex task by providing a shallow output, it forces the user into a repeating cycle. You tweak the input, reprompt, and try again, burning through massive computing credits and your own time just to get a competent answer. Opus 4.7 breaks this cycle by delivering massive, concentrated compute on the very first attempt for complex questions. It yields a complete answer immediately. The wasteful loop of reprompting is permanently bypassed. Preventing the need for corrections and reprompts is the ultimate form of digital efficiency. For years, performance was scaled by increasing the size of datasets and parameter counts. This transition to adaptive thinking suggests future games depend less on sheer volume and more on the precision of resource management. Because effort is not a virtue, applying it in the right place is. We are finally building machines with the discernment to know when to sprint and when to sit down and think.